Hey guys, and welcome to ArcTech. So in this video we'll solve a question based on dynamically allocated stack, that is a link stack. Now this question says write a function in C++ to perform push operation on a dynamically allocated stack containing real numbers. So here we have to write a function and we have to perform push operation, that is adding the element at the beginning of a linked list. And the data here is real number, that is every node will have data as real numbers. Now real number is nothing but float variable. Therefore inside the node, since we have two parts, first part is data part and second part is link part, so in the data part we have a float variable in this question because here we have real numbers. So data here is real number, so we will have a float variable inside this data part. That is, the structure of node will have float variable in the data part. Now, this solution for this question is totally based upon adding the element at the beginning of a linked list. So understand the concept first and then you can easily solve this question. Now, we'll see the steps that are required for solving this question. So here are the steps. The first step is that you have to create the structure of a node. Why? Because see, in a linked list or in a linked stack, every element is a node and a node is nothing but a structure. Now, this structure will tell the compiler that what are the contents of the node, that are what are the contents of each element. Therefore, the first thing is that you have to create the structure. That is, you have to write the code of the structure. So we'll see the code of the structure here. So in the structure, we write the struct keyword first, and then we write the structure name. Now the name here is node. You can use any other name if you want. So here the name is node, and then we have the two parts of this structure. The first part is data part and second part is the link part. Now in the data part we have stored a float variable. Why? Because the question says that we have to store real numbers. Therefore we have float variable here. The name of this variable is data. You can use any other name if you want. Second thing is the link part. Now here we'll have one pointer and this pointer name is next. Now understand one thing, that this pointer type will be same as the structure name. So here you can see node is the type of this pointer and this is same as the structure name. Now after doing this, we'll see the second step. The second step says that create a new node, enter data inside the node and then allocate memory using the new operator. So now we have to create the node. Why? Because to add a node we have to first create a node. Therefore we'll now create the node. So here are the steps for creating the node. The first step is that we have to create a pointer of type node to store the address of the new node. Why? Because in dynamic memory allocation we work with pointers and pointers stores addresses. Therefore we have to first create a pointer of type node. Okay, so node is the structure. Remember, node is the structure. So we have to create a pointer of type node and this pointer will store the address of the new node. So now we'll see how to create this node. So here we have the function. Inside the function we are taking two arguments. The first argument is the top pointer and second argument is a data, that is a num. So this is the real number that has to be inserted inside the new node, that is the data. So num is the data here. Then this top is nothing but the start pointer, that is the pointer that will point to the first element of the link stack. So top is a pointer pointing to first element. Now after this is the creation of the pointer. This pointer name is nptr and this pointer is of type node. So now the pointer of type node is created. So you can see the type here is node, and now we have to allocate the memory to the node and then store its address in the pointer created. So now we'll allocate the memory and then we'll store the address inside this pointer that is created. So here you can see we have used the new operator for allocating the memory dynamically, and then we have stored the address inside this nptr. So in this way we have allocated the memory and stored the address inside this nptr. So now after execution of this line, our node is created and nptr is a pointer that is having the address of this node, that is this pointer is pointing to this node. After this we have to enter the data inside the data field using the pointer. So now we'll enter the data inside this node. Suppose the node is like this. So we have this nptr here pointing to this node. Now the data here is num. So we have to store this data inside this data field. How can we do this? We have to first write the pointer name. Okay, so the pointer is nptr, that is pointing here. So we have to write the pointer name. Then we have to use the arrow operator, and then we have to use the variable name that is used inside this structure. So the variable here is data, and then so we have to use data here. So in this way we have accessed the data field, and then the value, that is num, is stored inside this data. So here after execution of this line, the value is stored inside this data field. After this we have to assign the pointer of the node as null. So here we have nptr to next is equal to null. This is the data pointer field, that is the pointer here. So the pointer of this node is assigned a value null. So this pointer is null because initially the node is not pointing to any node, therefore this field is null. So here after execution of this line, the node is created and the address is stored inside nptr. The value stored inside data field is num, and the null value is stored inside the pointer. Now after this the node is created, so we have the third point, that is check if list is empty or not. Now we know then when we insert the element at the beginning of a linked list, then we have two conditions. The first condition is that the list can be empty, and second condition is that the list can be non-empty. So we'll see both the cases. So let us suppose that the list is empty. So we have top is equal to null. Top is a pointer pointing to first element of the list or the stack. So here since the stack is empty, so we do not have any node here, therefore we have top is equal to null. Now after this, to add the element, that is the newly created node whose address is stored in nptr, what we'll do is we'll first make top point to this nptr, that is the value nptr is stored inside top. So after this we'll do top is equal to nptr, that is the value nptr is stored inside top. Now the value nptr is the address of this node, therefore this address is stored inside top. So after this top will start pointing to this. So in this way top will store the address of new node, that is nptr, and in this way we can insert the element inside this empty list. Now we'll see how to insert the element in a non-empty list. Suppose the list is like this. We have top is equal to 1000. This is the first node, this is second node. Now to insert the new node whose address is stored in nptr, what we'll do is we'll first make the next pointer of this nptr point to this first node. So we'll make this address stored inside this. Now this address is stored inside top. Okay, so we'll make this is equal to top. So we have nptr to next, that is this field, equal to top. Top is having value 1000, therefore this will have a value 1000 stored inside this. So you can see 1000 is stored inside this, and nptr is pointing to this first node. After this we'll make top point to this nptr. So we have top is equal to nptr, that is now top is having the address of nptr. So in this way top is pointing here, and in this way we can insert the element in a non-empty list. So we have to write the code of this insertion. So here we have the code for empty list, that is suppose the list is empty. So we have top is equal to null, therefore if the top is equal to null, that is if list is empty, then we have top is equal to nptr, that is suppose the list is empty, so we have top is equal to null. Okay, now to insert this element, that is nptr, what we do is we first make top point to this node. So we have top is equal to nptr. Simple. This is for empty list. Now let us see for non-empty list. So we have this part for non-empty list. So we have nptr to next, that is the next pointer of the new node is equal to top, that is the address of first element is stored inside this. So now nptr pointer is pointing to first node, and then we have top is equal to nptr, that is now top will point to the new node. So in this way we insert the element inside a non-empty stack. So this is the answer for this question. First you have to create the structure, and then you have to create the node, and then you can allocate the memory, and then you can add the element in the list.